All right, let's look at the power series. The series we have dealt with so far has terms that are just constant, but let's throw in some variables. And let's say each term is a power function, right? Then the sum of all those guys are called the power series, right? So it has this following general form, right? C0, some constant, plus C1, some constant times quantity x minus A. A is called the center, so this is a power series centered at A. And the C2, which is a number, times quantity x minus A squared. C3, quantity x minus A cubed, and so on. All right, and in summation notation, you can write it in this form. So this is going to be a summation. All right, so the power is going to start from 0. All right, then go to infinity, so it keeps on going. All right, you have a Cn, which is the coefficient. Then you have a quantity x minus a to the nth power. All right, this is a power series. All right, so let's look at a couple of examples of a power series, which turns out to be a function that we are familiar with. All right, so let's say you have x plus 1 plus x squared plus x cubed, and so on. Right, this is actually can be seen as a geometric series, right? Because if you look at the if you multiply between the first two terms, you multiply by x, right? And then if you go from the second to third, you multiply by x. So every time you go to the next term, you multiply by x. So this is a geometric series, and some of the geometric series is the first term over 1 minus whatever the r value, in this case x. So this is actually exactly the same function, add up to the function. First term is 1 over 1 minus r, in this case x, right? But the little disclaimer here, so you have x, if x, absolute value of x is less than 1, because otherwise it's not going to converge, right? So if you look at it as a geometric series, we know that the sum of all these terms is going to add up to this particular function, right? So that's the first example. Another example, we're going to explain how we get that later, but if you have 1, maybe I should have written it this way. So 1 is same thing as, you can think of it as x to the 0th power over 0 factorial. Remember that the 0 factorial is defined to be 1. And the second term is x to the first power over 1 factorial. 1 factorial is 1, and so on. So this can be written as, this is going to be a summation, right? And the n goes from 0 to infinity. And it looks like you have an x to the nth power on top. Then you have an n factorial on the bottom, right? This turned out to be the familiar function. This is actually going to add up to e to the x. We'll explain that later when we talk about the Taylor series and Maclaurin series. All right, that's it. I hope that this was clear.